Hi and welcome back. In this video, we're going to do some examples of function compositions with graphs. So I'm really just going to use one set of graphs here and then just ask you a lot of questions about them. So specifically, we're going to answer these questions with the following graphs, and here I have graphs of f and g. So let me provide you the questions I'm going to ask, and we'll work through them one at a time. So we're going to find g of f of 4, we're going to find f of g of 1, we're going to find g composed with f of 2, and we're going to find f composed with g of -3. So if you'd like, you can pause now and try these out on your own, but I'm going to go ahead and work through these. Alright, so let's start with finding g of f of 4. So remember, with compositions, we start on the inside and work our way out. So the function f is going to happen first here, and whatever we get as the output becomes the new input for the next function. So we'll start with f of 4. 4 is our input and x value, and we want to find the corresponding output on the graph. So I'm saying the point is 4, -1 on the graph of f, and so the output is -1. Now this becomes the new input to my function g, so I'm looking specifically for g of -1. So I'm going to go over to the graph of g and look for the point that has an input of -1. I see specifically we have the point -1, 0, so 0 is the output, and that will be our solution. So the answer to g of f of 4 is 0. So next, let's find g composed with f of 2. So we do the inside first, so we're doing f of 2, and then this will become the input to g. So to find f of 2, I'm looking at the graph of f. I see that the input of 2 corresponds to an output of 1, since the point is at 2, 1. So 1 is going to be my output that becomes the new input to g. So I'm looking at g of 1 now. So I go over to the graph of g. I'm going to use the input of 1 and see what the corresponding output is. There is a point at 1, 2, and so 2 is that output. So 2 is our solution. Alright, now let's find f of g of 1. So now we're doing the composition in the opposite order. So we're going to start with g of 1, where we input 1 to the function g. So we just did this in the last part, actually. The input of 1 corresponds to an output of 2 on the graph of g. So 2 is going to be our new input for f. So g of 1 is 2, and 2 becomes our new input. Now I'm looking for f of 2. So I go over to the graph of f, and I find 2 as an input and see which output it goes with. So I see that 2 corresponds to 1 as an output, since the point is 2, 1. And 1 would be my answer. Alright, then lastly, let's find f composed with g of -3. So we're going to do g first, and -3 is our input. I see that it corresponds to the point -3, -2, and so -2 is my output that becomes the new input. So I'm actually looking for f of -2 now. So I'll go over to the graph of f and look at the input of -2. I see that this corresponds to the point -2, -1, and so -1 is my solution. So in all of these, we really just do one piece at a time. We start with the first graph, figure out where the point is, get the output. That output value becomes our new input value, and then we find the next point on the next graph. Okay, so something you might see if you're doing a lot of these problems is that we often put these graphs on top of each other when we're doing their compositions. So I just want to give us a little practice doing that. I'm going to put both the graphs f and g on the same axes. So this can be a little more complicated since you have to manage everything on one graph, but it's pretty common for teachers to do this when they're giving these types of problems. So here we have the graphs f and g, and let's answer 4 more questions. So I want to find g of f of 6, then f of g of -1, g of f of 5, and then lastly, let's find f of 4. This time we're going to compose f with itself. Okay, so I'd like you to pause the video and give this a shot on your own. This is the same process as the example we just did, except now the graphs are on top of each other, so you really just need to make sure you're looking at the correct graph. Alright, let's do this together. So first let's do g of f of 6. So we're looking at the input of 6 on the graph of f. I see this corresponds to an output of 3. So 3 becomes my new input. That means I'm now looking at g of 3. I make sure I'm referring to the correct function, and I see that 3 corresponds to an output of 4 on the graph of g. And so 4 is my answer. Alright, now let's do f of g of -1. So I do -1 as an input to g first. I see that this corresponds to an output of 0. So 0 is my new input for f. So I'm looking at f of 0 now. I see that 0 gives an output of 3 on the graph of f, and so 3 is my solution. Alright, now let's do g of f of 5. So we do the input of 5 on the graph of f. I'm seeing that this has an output of 0, and now that 0 becomes the new input to g, so I'm looking at g of 0. So g of 0 gives an output of 1. So if 0 is the input, this corresponds to an output of 1 on the graph of g, and 1 would be our solution. Alright, we're almost there. Let's just do this last one where we do f of 4. So I see that if I have 4 as an input, f gives me an output of -1. So I have -1 as my output, and that now becomes my new input. So looking at the graph of f, if I have -1 as my input, we're getting basically 2. Let's just say 2 to make it easy here. So 2 would then be the solution. So again, we did 4 gets mapped to -1, and then still looking at f, -1 gets mapped to 2. And so 2 is our answer. Alright, so those are some examples of how we do compositions with graphs. Thanks so much for watching, and I will talk to you in the next one.